Welcome to the HVAC Quick Info series. This is Norm Christopherson, your host for this series of short lessons on heating, ventilating, air conditioning, and controls topics. In this lesson, we will learn how to measure airflow or cubic feet per minute using a voltmeter, ammeter, and a thermometer. Normally, airflow is measured using special instrumentation made for that purpose. Most mechanics or technicians do not have such measurement instruments readily available, so here's an alternative. However, this method can only be used when an electric heating element is available and installed on the system. Fortunately, many systems do have electric elements on board. As an example, we will use this residential electric furnace. A blower pulls air back from the return air section, moves the air across a set of electric heating elements, and sends the heated air out the supply air or discharge air duct and into the rooms to be heated. We have placed thermometers in both the supply airstream and the return airstream. The thermometers must be placed out of the line of sight of the electric heating elements. We want to measure the temperature rise of the air, but not pick up any radiant heat from the heaters. This is very important if we want an accurate air temperature differential measurement. With the blower on and placed in the desired speed range, we need to measure both the voltage at the heating element and the amperage drawn through the element. We must use actual measured values of voltage and amperage. We do not want to use the nameplate voltage or amperage listed on the heater. We need actual measured values. We will use the math equation on the left. The airflow in CFM is found by dividing the actual output BTU per hour of the heater by the value of 1.08 times the temperature differential of the air. The value 1.08 is a conversion factor that makes this equation work. Don't concern yourself with where I got this 1.08 factor now. I'll discuss that factor in another lesson, as this factor will come up again and is very useful. However, what you need to know is that the factor of 1.08 is accurate for use at sea level altitudes. For practical purposes and accuracy, I would be adjusting this value for every 1,000 feet or so above sea level. Again, I will address this in a separate video lesson. Now we will need to determine the actual BTUH or BTUs per hour output of the installed electric heater during actual operation. For electric heat, BTUH is power in watts multiplied by the conversion factor of 3.42. There are 3.42 BTU of heat per watt. This is true for all types of electric heating devices. So we will be multiplying the voltage to the heater by the amperage through the heater to obtain the power in watts. Then we will multiply the watts by 3.42 to obtain the BTUH. On the bottom half of our equation, we will multiply the factor 1.08 by the measured temperature differential of the air. Finally, we will divide the BTUH by the result of the bottom of our equation to obtain the airflow in CFM. We now see that we have some values. Notice that we have a return air temperature of 90 degrees and we have 110 degree supply air temperature, giving us a 20 degree air temperature differential. We've also used a clamp-on ammeter on the coil of the electric heater, and we've measured 18 amps there, and we measured the incoming voltage at the heater of 234 volts. We put those numbers into the equation over on the left, and we have 234 volts times 18 amps times our conversion factor of 3.42 BTUs per watt. And on the bottom, we have our number 1.08 times the 20 degree differential in air temperature. So we can do the math. With the multiplication on the top done, we have a number of 1,440.5. And then the 1.08 times 20 on the bottom gives us a factor of 21.6. So now all we have to do is divide the 1440.5 by the 21.6 and we will have CFM. So the result of our arithmetic is 666.9 CFM. We're going to round that up to 667 CFM, and that is about the amount of air necessary for approximately a 1.5 ton air conditioning unit. Even though we were in the heating cycle, when we used this method to get our airflow, if we were to switch over and use the same fan speed but be in the cooling cycle, we would still have 667 cubic feet per minute, and we would be in cooling instead of in in the electric heat cycle. So here we have an example where you might have an air conditioning system or a heat pump that has an electric heater, and you can use the electric heater to get CFM, and then that CFM in that same fan speed selection would be the same airflow whether you were in heating or cooling. Hopefully you have found this lesson in the series titled HVAC Quick Info Series useful. Be sure to locate and view the other lessons in the series and keep adding to your storehouse of heating, cooling, and controls knowledge database. Until next time, this is Norm wishing you well.